My name is Aaron, and I'm a mechanical engineer at the consulting firm TL Circle 3D Modeling, based out of San Francisco, California. And today I'm going to show you how to use Matterport's 3D camera for as-built documentation. For retrofit projects, manual as-built verification or creation tends to be a massive time suck and not particularly accurate. And for tight mechanical rooms and for services such as CFD modeling, accuracy is critical. I've explored other reality capturing tools such as photo stitching and 3D laser scanners. However, photo stitching has never really worked for documenting buildings, and 3D laser scanners work, but the scanning process and then the post-processing afterwards tends to be quite time consuming. And the scanners are pretty expensive, making the whole ordeal not economically viable for most retrofit projects. Recently, I found Matterport's 3D scanners used for creating virtual walkthroughs and 3D point clouds that can be traced in Revit or in AutoCAD to generate highly accurate as-built models. For instructions on the actual scanning process, you can go to Matterport's website, and under their support page, they have various different guides for the different types of spaces that you may need to scan. For this demo, I'm going to show a domestic hot water heater retrofit project where the water heaters and much of the piping system in the mechanical room of a high-rise apartment complex needed to be replaced. Space was limited, so generating an accurate BIM model to make sure that the replacement equipment would actually fit was pretty important. The scanning itself took about an hour, and then we spent about another half hour to an hour documenting the overall dimensions in the space, such as wall-to-wall and floor-to-ceiling heights. And then also took some spot measurements, one in case we needed to go through and scale the point cloud itself to fit the area, and then also to check for the accuracy of the point cloud itself. What's nice, though, is that if after the fact you missed any particular area, you can always go back and take additional scans and add that to the point cloud. For my workstation setup, I use three 30-inch monitors where I keep the Matterport virtual walkthrough along with the recap version of the 3D point cloud off to the side for inspection. Then I have Revit to where I have it spanning across the other two monitors. On the one in front of me, I like to use is my main drawing area where I have the floor plans along with the section views into which I like to draw in. Off to the other side, I like to have a 3D representation of the model so that I can see what I'm drawing is actually what I intended to draw. To get started, you'll first want to index the XYZ point cloud given to you by Matterport through Recap 360. So create a new project, select the file, and then just click through in order to create the RCP file that you'll bring into Revit. I'm not going to do that right now because it takes a few minutes. So instead, I'm going to show you a file that I already created previously. You'll want to do a quick visual inspection to make sure that the point cloud looks appropriate. Then do a file save as and bring it into Revit. To do that, go to Insert, Insert Point Cloud, select the file, align it to the space, and you may need to rotate it. And you'll also want to check the height of the point cloud and make sure that it's lined up appropriately. Generally, the point clouds that I've been using have been spot on with accuracy with the dimensions of the actual space. But if for any reason that it is off, you can easily adjust the scale of the point cloud by selecting it and going to Edit Type and then adjusting the scale there. You'll next want to adjust the view range of the floor plan view that you're going to be working in. To do that, go to the viewport's view range, click Edit, and then just play with the settings until you get it to exactly where you want it. Generally, you want to trace out trace in the floor plan or in section views. And I like to have section views that are bounced between one facing north-south and then another one facing east and west. And one way to be able to make sure what you're drawing is actually what you want it to draw is you can also create a 3D view and then orient it to the section views as you're going through and doing the drawings. And this just makes it so that it's a little easier to see, what's going on within your project. Watching somebody trace a point cloud inside of Revit is not the most entertaining, so I'm just going to do a quick demo of the outside air duct within the mechanical space. Like I said, I tend to draw mostly from the floor plans and section views because drawing in the 3D view in Revit is pretty difficult. So one thing you can do to keep from accidentally selecting the point cloud as you're tracing is you can pin it and then set it so that you can't select pin objects. And here is the outside air duct. I'm going to delete that out first. And then I'm going to start tracing. I don't worry too much at first about the height of the duct. I just go back and edit that later. I just kind of start by getting the just kind of the rough layout of what's happening there. So like I said, I like to go through and bounce between the floor plans and the section views. Until I have things lined up. And I got pretty lucky that the duct was actually at the correct height from the get-go. And then and to double check it, I'll go to that 3D section view that I created earlier and align it to which I was drawing in to begin with, just to see that it looks all right. And that is how you trace a point cloud in Revit. So that is it for this video. I would like to give a huge thanks to Dan and his crew over at Matterport for building the scanner and then helping me learn how to use it and apply it to this particular project. If you have any questions, feel free to reach out to me at aaron@tlcircle.com. Thank you.